Yes, in this video, we will see next question from a LeetCode 75 list. Let me take you to the screen first. And here, in this question, which is a delete node in a BST, what's written? Let's read. Given a root node, reference of a BST and a key. Okay. Delete the node with the given key in the BST. Return the root node reference, possibly updated, of the BST. Basically, deletion can be divided into two stages, that is search for a node to remove, and if the node is found, delete the node. So basically what they are saying ki we are giving a value of that node. First search that node, that valued node, the value which we are giving. Search a node whose value will be equal to that value, and if that node present in that BST, then delete that node. That need to be performed in this question. Okay. Here they have told key that is return the root node reference possibly updated of the BST. What they said key possibly updated, it means ki we need to delete the node, or we will need to update that node's value basically, and we just need to delete a node whose value is equal to that key value. Okay. Yeah. So how we will solve it? First, we need to search it. In binary search tree, how we search, that we saw in last video, that when we need to search a node, and now we after searching that node, we need to delete it. Okay. By, to search a node in binary search tree, how we search, that we will first see. We'll directly, I'll write a code, and while writing I'll tell you that how it is, how we are doing it. Okay. Now if my root node is null, then will I find a key? No, right? So what I will say, if my root equals to null, then just return that null, that return the null, or return the root, or root is null only. uh, okay. If my root values, uh, if my root value is greater than the key, then what? If my root value is greater than key, then the key node must be present at left, right? Because it is a binary search tree, and at the left side node will be the lesser value than the root value. So if my root value is greater, then my key must be present at left. So what I will say, key go to the left, and what I will say, okay, go to the left and delete that node. And as we need to return the updated tree, that updated tree means what? Delete that node from that tree and return that tree, whatever the tree will be formed after deleting that node. So that tree will be at root's left, right? Cause root root value is greater than the key, and we are deleting that node from the root's left. So whatever deletion will happen, it will be happen at left side, and that need to be updated for that root. So whatever will happen, just keep it updated to my roots left tree. That what I will say. That what we understood, right? So here we will write key go to the left here, delete that node, and correct my root left sub tree basically. What if else if my roots value is less than my key, then my node will be present at roots right side, cause key is greater. So in that case also, what we will do, key I'll say key delete that node from my right subtree, and return that subtree basically. And as we are correcting the roots right subtree, and we are going to the right, I will say ki correct my right, that roots right will be now, roots right will be roots right subtree will be the subtree which is deleting that node, deleting that node from the tree. So delete node from roots right, and return that root, return that tree basically, and that subtree will be present at my roots right. Now the main part, which is what if my roots value, else the only one thing is left, right? Which is my roots value can be greater than key, my roots value can be less than key, and my roots value equal to key. We took the two conditions here, and now only the one condition left, which is root value equal to key. If my root value equal to key, what I will do? Now if my root value is equal to key, then that root node, basically that node can be my child node, right? Can be my child node, or can be a node whose only left part exists, that is the node which have only left child, or the node which have only the right child, or the node which have both child. These cases can happen, right? First we will take a case in which, case 1, which is no child, for that, for the node, no child. Okay, we'll say ki no child, or we can say it is a leaf node. In that case, what I can say, if it is a leaf node, then just delete it, right? If it is a leaf node, then just delete it. And how we can identify it is a leaf node, that is the node which I do not having child. If my root node left is also equal to null, and my root node right also equals to null, then it means that it is a leaf node, right? And if it is a leaf node, delete it. So delete the node, or you can say delete the root and return the null. Okay. Else, as we are returning, we can write like this only. Instead of writing else, we can write the what if we'll take the second condition, in which I'll say the case 2, only we'll say ki only one child that root have, or that node have only one child. In that case also, we can say ki I can have the left child or the right child. I can say ki my roots left is not equal to null, and my roots right equals to null. It means ki I have left child but I don't have right child. In that case, what I can say ki okay, so I don't have any right. There is no one there is no one at right. So for me, if I'm I have a left child, and I have to be deleted, that my value is equal to key, then I have to be deleted, and my left one need to be written from my place only. As I'm getting deleted, the left value will be at my place, and that tree will be written. So what I will say ki take a root node, that is not a root node. We can say ki a node which is node need to be written, need to be written it will be roots left, right? Because the root need to be deleted, and that root left need to be written. And I will say ki delete that root and return that node which is need to be written. Or the second case, like only one child, second case, which is my roots right exists but my roots left doesn't exist. That roots left is equal to null, that is my root left is equal to null. I don't have left child, but I have a right child is not equal to null. So in that case, what I have to do, as root itself need to be deleted, it will say ki okay, delete the right delete me, and return the right node. So what I will say here ki the node which need to be written, it will be roots right, and that root need to be deleted, and we need to be written the node which we need to be written. Okay. Now we will have a case in which, this is the third case, in which root node will have both child. If root node will have both child, in that case what we can do, as we need to follow, like we need to delete that node also, and also after deleting that, there should be a node which will connect that both subtree, right? And that node's value should be satisfy the condition in which the node which we are replacing, that node, basically the node, now we need to delete the node, and that node have a left value, and left child and the right child. Now I can say कि after deleting that value, I need to be replaced with it one of node, so that that node's value should satisfy the conditions, uh, which is the left value should be less than that node's value and right value should be greater than that node's value. Okay, I think recording stop. 1 minute. Now, so uh, let's think if which value can I can replace with that, like which node, with that node I can replace my root node, so that this condition also will be fulfilled and that node will also get deleted. So if I think, if I go to the, like I'm thinking, right, I'm thinking ki, if I go to the right side, as example number one, they have said कि they wanted to delete 3 and it went to the right side and took a right, and as the 4, and it 3 get replaced by 4. Likewise, how can I do it, that I'll just replace the right node with that node? If I do that, then what can happen? My right node will have the left nodes also, and that root itself have that, the node which I'm deleting, that one also have a left node. Then how we can do it? So though I cleared key, okay, I can replace it with the right node, but if my right node have the left child and right child both, then what I can do here? Can I say like this key? Okay, what I can say key, delete it with delete it and replace it with right child, and then delete the right child likewise. But before that, I can do something else also. Or if I do that, uh, the left one, what I'm saying is that nodes are less than the root node, the node which we are replacing, and that node, uh, how we can basically, okay, I have to go right, that you clear, right? I will go right, and I will go to the leftmost position of that right. Through that node, what will happen? Ki the node which I am getting to the leftmost of my right, that node's right side always will be the greater, and the node which I am replacing, that the node which I am rating, that's right also was also greater, and that node's left was less than that node. And as it is a node which is at the node which I am deleting, that's right side's leftmost, and it is at the right side's left node, it means ki it was a greater than the node, its value is greater than the node's value, but it is less than the rightmost right ones. Okay, so I can replace the value which is at right, leftmost of my right, with that node. I can replace my current node, cause I need to be delete this node, or I can update this node, and I can delete the node which is at my rightmost left, or leftmost right, sorry, which is at right and the leftmost of that right. Okay, so how we can do that? What I just said, key, go to the right and go to the leftmost. So for that I need to take a current node, which will be the right's left. Current node will be my root's right, that will be my current. And what I will do, ki I'll go till my current exists, and I'll go to the current left. my current left exists basically, and I'll go current equals to current left. Likewise, we will go leftmost of my uh, roots right, or we can say nodes right. And after that, what I will do, my root value, I will replace my roots value with my current value. As I said, till the current left exists, I need to go. So I have the current value that I know now. And what I will say, replace my root value with my current value, and uh, the roots right, go to the roots right, as that current node was the roots right, and delete the node with my current value. Okay, I can take this, delete the node with my current value. As I replaced my root value with my current value, now I need to that node need to be deleted, which is now duplicated. And yeah, that's what we will do, and we'll return root. Okay, so let's run it. And I think network problem again. Okay, run it again. What it is saying ki, something need to be written, so I'll say ki okay, uh, I need to return root, so I'll return root. And I'll submit it. It is accepted. Okay, what will be the time complexity for this? As I am visiting all nodes to check if that node is present or not, the time complexity for this will be big of n, and n will be the number of nodes in that tree. And what will the space complexity? The space complexity for this will be height of the tree, as I'm doing the recursion, and also, in that recursion I'm using a internal stack, and in that internal stack the height of the space which is getting used by internal stack is equal to number of calls will be done in that recursion, and number of calls will be done in that number of functions call will be done in that recursion is equals to height of that tree. So space complexity will be height of the tree big of h. And yeah, that's it for guys, and we'll meet in next video. Till then, bye bye.